Nonlinear trend forecasting module prepared by Professor Amit Dada, School of Business, George Mason University. Sometimes the time series data based on which you want to forecast when you plot the data, like you see on the chart on the right hand side, does clearly exhibit a trend, but it's also evident that the trend is not a linear one, it's a nonlinear one. So then how does one go about forecasting trends which are nonlinear? Obviously, nonlinear covers a lot of ground. Nonlinear shapes can be an infinite number of different shapes, but we'll start with some simple alternatives. The simplest sort of nonlinear trend that one could get is a quadratic trend that you see over here. So if I look at the picture of revenue over time that I see in the chart, I'm superimposing a quadratic trend on it. What that means is I'm saying that revenue is equal to an intercept B0 plus a coefficient B1 multiplied by the x-axis, which is time in this case year, plus a second coefficient B2 times year squared. That's where my nonlinear component comes in, and in this case I'm assuming a very simple quadratic trend. Now this may not be the most accurate for this particular situation. I'm just bumping it up. I realize just looking at the chart that it's not linear, so I add a quadratic term. You can extend this logic and you could have a term that is year to the power 3, year to the power 4, and so forth, which would give you a polynomial trend. And then of course you can have exponential trend patterns and so forth, but you get the basic idea here that the trend visually when you see it is not linear, so one would need some kind of a nonlinear approximation for the trend. Now which particular nonlinear formulation is appropriate depends on the particular situation, forecasting situation at hand. In this example we're looking at sort of the simplest nonlinear trend equation that you could be estimating for the trend, which is a quadratic trend. So let's see how one would go about determining a quadratic trend for forecasting purposes, assuming of course that the quadratic is the appropriate way to go. So let me move this picture in the chart down a little bit. So I will also move this dependent variable a little bit so that it makes space for me for the year squared, the second variable. Remember we had the quadratic term, so this is basically year squared. So in this column I simply take the x variable and I square it. So 1 times 1, I just copy this formula down to the remaining cells, and there I have year squared. So I'm all set with my independent and dependent variables. So I will just now know, in order to get the coefficients b0, b1, and b2, I would run a multiple linear regression um, with the independent variables being year and year squared. So let's do just that and see what we get. So here's data analysis. I would do regression, and my dependent variable would be revenue. And my independent variable, in this case there are two independent variables, year and year squared, and the output, let's put it in cell EG2. So there's my regression output. Okay, so the quadratic trend equation that I come up with is revenue is equal to 24.18 plus, I'm sorry, minus 2.11 times year plus 0.92 times year squared. Okay, so let me make the square, well, that should be year squared. Okay, So there's the equation. And once again, the coefficients have come from here. The intercept is 24.18. The coefficient for year is minus 2.11. I've just rounded it off to two decimal places. And the coefficient for year squared is 0.92. Okay, so if I had to predict the sales for year 11, revenues rather for year 11, I would have revenue is equal to 24.18 plus, again, sorry, once again, minus 2 point times 11 plus 0.92 times 11 squared. Okay, so whatever this value comes to, that would be my prediction for revenue. Uh, just as in actually the trend portion, or just as in the case of linear trending, something that's also often done once you get this quadratic equation is to detrend the data. That is, take the actual value of revenue that you have for this 10 years, and then using this equation that has been derived from the trend equation that's been obtained, plug in the different values of years and remove the trend from the raw data. That will leave you with the random fluctuations that occur around the nonlinear trend line, and then you could use moving average or exponential smoothing to forecast that piece of the data. So once you get these two pieces of the forecast, the random variations as well as the nonlinear trend, then you could splice the two back together to get an actual forecast for period 11 or period 12 and so forth. So this is a simple extension of the linear trend situation to do forecasting, where one has nonlinear trends, and in this case the nonlinear trend is that has been superimposed on the data is a quadratic trend. And just recognize that there could be other nonlinear trends that might be appropriate.